Now, the next one is conservative versus non-conservative forces. What is a conservative force? Special kind of field in which it doesn't matter how you get from point A to point B. Whereas a non-conservative force is a force in which the work done depends on the path. So in my head, I usually think of conservative forces as those where friction is 0. And non-conservative as those ones where friction exists. So it's a very simple definition to remember. When friction is 0, it doesn't matter how you get from point A to point B, right? You can go this way, what?
You need direct eye contact to maybe ask that question.
I wasn't thinking. Or you go from here to here. It doesn't matter how you get there. However, will this hold true for a non-conservative force or a field? Right? So for a non-conservative field, it will depend, which one will be the least work required? Right, the black one, right? So if I call this path 1, 2, 3, 4, for a conservative force, it won't matter which one you take because there's no friction. However, because remember the definition of work is force times delta x, right? But for a conservative force, it doesn't matter whichever path you take. But for a non-conservative force, which path would you want to take? Right? Anything longer would require more work. And as we all know, the universe is inherently lazy. Doesn't want to do any more work than you have to. Let's just define this first. Proper definition. When work done in moving a particle from point A to B is independent of the path taken. Whereas in this case, depends on the path taken. Right? Everything else remains the same. I'm just being lazy. I'm part of the universe. Don't want to write the whole thing. So an example of this will be gravitational field. And an example for this would be or drag. So now the conditions for these. Number 1, work done along a closed path will equal 0. Everybody understands what this sign means, right?
Yeah.
The work done along a closed path integral equals 0. What do you think this term means? Yes.
Closed path.
That's what it means.
This is a whole line, right?
Yep. It's a closed circle. Now, it doesn't mean it actually has to be a circle, right? It could be that. That's a closed path, as long as it starts and ends at the same point. Okay, so what about on the other side? So the work done, what's the condition for a non-conservative force? There we go. Who said that? Excellent, good job. Work done along a closed path will not equal 0. Okay, number 2. Force can be written as the negative gradient of potential. So watch the words very carefully. Force can be written as negative gradient of potential. So why negative? What did we just say the universe was? Good. So why negative?
Because
Where does it want to go? Towards the higher potential or the lower potential? That's why we have the negative. Because the universe wants to always go towards the lower potential, right? If it's an excited state, it wants to go to the ground state every single time, no matter whether you're talking quantum mechanics, classical mechanics, whatever you're talking about. It always wants to not be in an excited state. So can anyone take a wild guess on non-conservative force? Cannot be written as this.
yeah.
Well, that's a terrible U. People are going to ask me. That's a V. It could be a U too. It's potential energy and potential. So everybody understands the difference between potential energy and potential, right? Okay, yeah?
Can you remind me?
Okay, well, so potential is what the field creates. Potential energy is what is gained by a particle in that potential. So everything creates a field. Earth has a field around it. It attracts the moon. The sun has a field around it. It attracts the earth towards itself, right? So potential energy is a U problem. You have more potential energy because the virtue of pure. Got it? Potential energy is what you have gained. Potential is by the virtue of the fact that you are on earth, right? Potential is what is provided by the field. Number 3, curl of F is 0. Okay, what is a curl? This is from physics 1. A curl is a rotation about its spot. Okay, so if things turn, they give you curls. So if you're talking about forces, the curl of a force, if it is in a conservative field, it'll be 0. So can anyone guess what it would be for a non-conservative one?
I'm gonna throw a guess out there and say it's not 0.
Done. Very good.
So the gradient is.
So this one is the gradient, this one is the curl.
Wait, that one's the curl, that one's
This is the gradient. That's the definition of a gradient.
Would that be?
They're using the same symbol. though,
Yes,
right?
yes. So yes, it's the same symbol. It's like a dot product versus a cross product. You use the same symbols, except they mean very different things.
You don't use the same symbols. This dot is with the dot.
Right, but it's same with vectors. So you either write A dot B or you write A cross B. So technically, you're using the same A's and B's. I'm using the same things, sort of.
Oh, my bad.
Yeah. Yes, so yes, but they mean very different things. Okay, now what do they mean? So what is this funny looking symbol I've just used? That is called a del. Is called a del.